In this video, we're going to learn how to multiply radical expressions. And I'm just going to make up an example, and on the right side, I'm going to pull this down and list the steps that I am doing. So the example I want to try is number 9 on your paper, which says negative 3 times the square root of 7r cubed multiplied by 6 radical 7r squared. Okay. And the first step that I'm going to use is, well, I'm going to leave this up to you of what property I'm using, but I'm going to use a certain property in math that allows me to rearrange this expression. And just so you can see this a little bit more clearly, we know that between each of these expressions here, negative 3 and square root of 7r cubed, there's a hidden operation, and that hidden operation is multiplication. Okay, so I'm just rewriting this, and I'm going to do it in different colors to allow you to see what I'm going to rearrange. Okay. Okay. So this is not my first step. I just rewrote the problem in different colors, and as you can see, I have 1, 2, 3 multiplication signs. A couple were hidden, and then our original one, of which we're multiplying the two radical expressions. Okay, so now I'm going to rearrange this, like I said, and I'm going to put what's in blue together, so negative 3 times positive 6, and then still multiplying all of this stuff. I'm going to take my square root of 7r cubed times square root of 7r squared. Okay, and I put them together. And my second step here is just to simplify my expression for what I can. So, in 6th grade we learned how to multiply two numbers, one being negative. So a negative 3 times a positive 6 gives us a negative 18. And we've been working with multiplying radicals. We know that if they have the same index, so these are both square roots, we're allowed to put them under one radical. So that's what I'm going to do in my next step. And I'm going to say 7r cubed times 7r squared. Okay. And now I'm going to work inside the radical. Remember when we have two bases that are the same, so the 7's have the same base, they have exponents of 1, so 7 times 7 is a 49, and r to the third power times r squared. Again, I'm using this hidden property here inside. I multiplied the 7's first, and now I'm multiplying r cubed times r squared. And I remember my shortcut is when I have the same base, I add the exponent, so this becomes r to the 5th. And I don't want to forget to bring down my negative 18 times this. And so that's pretty much it, unless, if it's possible, we can simplify inside the radical. So this is what we worked on yesterday. And again, I'm just going to bring down my negative 18 for right now. And I know that inside this, remember, we can think of this as two square roots, the square root of 49 times the square root of r to the 5th power. The square root of 49 is a perfect square. It's equal to 7. So since we have a positive square root, I'll take the positive factor, negative 18 times 7. And now we're going to be left with r to the 5th. And a review from yesterday, negative 18 times 7 is 6. Negative 126 times r times r times r times r times r. And I can pull out pairs. So since I have two pairs of r's, my final answer becomes r squared times the square root of r is left. And if I wanted to write that a little more shorthand, there is my final answer. Okay. Let me know what questions you have now.